Alright, so when we finished section 10.1, the very last thing I showed you guys was a different way that you could write a system of equations that was shorter, and that was called a matrix. So today we're going to solve systems of equations, but the way we're going to do it is to use a matrix. Okay, I'm not going to do this one because this would review what we did before, solving with elimination. We're going to do this, but I'm going to show you a matrix first, and then we'll come back and do it with that. All right, so rather than using substitution, we're going to transition now to using a matrix. The idea with a matrix is it's kind of like elimination. The goal is going to be to get rid of certain variables. Okay, we're going to try to create things that cancel out. And when things cancel out, we get a zero. So that's the goal. We're going to try to get some zeros. So first of all, the way you describe a matrix is by the number of rows and columns it has. So if you're looking at a matrix that had 2 rows, 5 columns, you would say that that's a 2 by 5 matrix. That's the dimensions of it. Rows. That's 2 rows, 3 columns. So that would be a 2 by 3 matrix. And we're going to be working with just 2-dimensional matrices. Rows, columns. You can have 3-dimensional matrices. It starts to get a little more complicated. You probably think of like, imagine like a cube. And there were all these like slots in the cube. You'd have like a level you could go in the cube. You'd have a left and right you could go in the cube. And then you'd have a front and back you could go. So if there were different slots in the cube, you would describe it as 3 letters. What's the width? What's the length? What's the height? Okay, but we're just going to do 2-dimensional matrices. If the number of rows and columns are equal, okay, that is called a square matrix. So a square matrix is when the number of rows is equal to the number of columns. The things that you put in a matrix, those are called the elements. In our case, all the elements are going to be numbers. But if you were using a matrix to like do something on a computer, like in a computer program, matrix could store names of people, could store words, colors. A matrix can store anything. We're specifically going to just store numbers. So the notation that you generally use to name a matrix is a capital letter. Capital letter. What would be the dimensions of this matrix? Yeah?
3 by 3.
Yep, that's a 3 by 3 matrix. And because it has the same number of rows and columns, it makes it a square matrix. Yep. Now, if you want to refer to a specific element in the matrix, okay, what element is in row 2, column 3?
3.
9. 3 is row 3, column 2.
Oh. 9.
9. Second row, 3rd column. Okay, so what's in that spot is a 9. If you want to kind of abbreviate how you can say that, that's how you can write it. You use a lowercase letter corresponding to the name. So our name was capital A. If we want to refer to an element in it, we could use a small a. And then the subscript 2, 3 means row, column. So row 2, column 3. Now, when I asked what was in row 2, column 3, we got the correct answer. We got 9. And the way that we count rows and columns is we start with 1. Okay? Most of the time, when you do like any kind of programming, you don't start with 1. Anyone have a guess what we start with?
0.
We start with 0. So this would be called column 0, column 1, column 2. Row 0, row 1, row 2. If you use 0, I mean, it's fine when you're programming, but it starts to confuse people when you do this. So we're just going to stick with row 1, row 2, row 3. That's an easier way to think about it. Any questions on that? All right. So what's really the advantage of a matrix? Well, we don't have to write any letters. So all the work that we do today, there will be no letters in any of it. And letters are half of what you write down. Look back at these equations that I skipped solving. Probably more than half of, well, I don't know, maybe half of that is just writing down letters. We also don't have to write down the equal signs. Okay, we're going to have a symbol that represents the equal signs too. So it's going to be a lot more condensed. So if we're not writing down letters, then what are we writing? We're just writing the numbers that would be in front of the letters. Okay, so all you have to do is write down coefficients. So if you had a matrix, or let's say you had an equation like 2x plus 3y equals 5, negative x plus 6 equals 7. If you were going to write that as a matrix, all you do is write 2, 3, negative 1, 6. That's the left side. Put a vertical line. That's what separates the left from the right. 5, 7. So when you have to keep rewriting this a lot, that's a lot shorter. So the idea is that each column has to represent a specific letter. Okay, the way I did it, the first column are the x's, the second column were the y's. Okay, that's important. And generally, I would recommend doing it that way. I would always have your first column be the x, your second column be the y's, and if you have the third column, what do you think that letter would be?
Z.
That'll be the z's. Yep. Now, when you write this down, this part right here, that 2, 3, negative 1, 6, that is all the numbers that were in front. Okay, those are called coefficients. So this whole thing that I circled is called the coefficient matrix. It's just a table of all the numbers that were in front. Now, if that's all you write down, the coefficients, you're going to be missing the whole right-hand side. So what we have to do is add on to that. So we put this line and augment or add the right side, the 5 and the 7. Okay, so what we do is we add on to that matrix a column that represents the 2 numbers that were on the right-hand side. Or if we're doing 3 equations, it'll be 3 numbers. So we add on a column that represents the constants. The numbers, what's on the other side is always going to be a constant. There won't be any letters on the right-hand side. Just like this. Negative 1, negative 3, negative 2. All constants. Okay, and all the work that we do is going to be done in the matrix. That's how it's going to work. So I'm going to show you how you do it. But has anybody worked with matrices before to solve systems? Okay. So the real advantage of what I'm showing you is the method that we're going to learn to solve matrices. It's something that's very easy. Well, not easy, but it's something that you can program into a computer. Right? There are no options. Like, all right, well, should I do this or should I do that? Or then once I pick that, should I pick this letter or should I pick that letter? When you have to make decisions, that's not really something that's always easy to program. But there's no decisions in this. It's a method. You follow the same method every single time, no matter what the problem is. So when you always do the same thing over and over, that's where it's very easy for a computer to do this. All right, so what is the goal? That's the goal of every problem we're going to do today. We have to transform the coefficient matrix. That's the part that's on the left side. So that we end up with a lot of zeros in it. Specifically, I want to get zeros below the diagonal, and I want to get ones on the diagonal. Okay, so here's an example of a matrix, like what that looks like. Where I put squigglies, I don't care what's there. Anything you want. But this, I definitely have to make happen. Okay, I got to get ones on the main diagonal, and I want to get zeros everywhere below it. There's another example, a little more generic. Just ones on the diagonal, zeros everywhere underneath it, anything you want up above it. When you turn your matrix into what I have right here, okay, zeros below it, ones on the diagonal, that's called row echelon form. Okay, I'm going to refer to that as REF. So if you see a problem that says solve the system by changing your matrix into row echelon form, it means ones on the diagonal, zeros below it. Now there's something you can do to take that one step further called reduced row echelon form. We don't do that. But the next step would be to get zeros above the diagonal. So then you have zeros everywhere above, everywhere below, and ones on it. Again, we don't do the second part. Instead of doing the second part, we're going to go back to substitution. So those are pretty much your two choices when you use a matrix like this. You either do row echelon form and finish with substitution, or you do reduced row echelon form for the whole thing. But we're going to do the substitution. All right, so how do you get something in row echelon form? How are you going to get ones and zeros in those spots? There's only three things that you are allowed to do when you have a matrix of numbers. If you do anything other than these three things, it will mess up your answer. Okay. So one thing you are allowed to do is you can take any two rows and you can swap them. You cannot swap columns. No way. Can't do that. But you can definitely swap two rows with each other. The other thing you can do is you can multiply a row by any number except 0. So that's like, we kind of did that. I think we had a problem in the homework, maybe had an equation like that. And we multiplied, we divided, but you could think of it as multiplying everything by 1/2. Okay? What multiplying by a constant can do is it can make all the numbers in your equation smaller. Or, if you had something like this, you could multiply by a certain number here to make these cancel out. That's pretty much what we're going to do with a matrix. So you are allowed to multiply a row, an equation, by any number except 0. And then you can add one row to another. That's exactly what we do in elimination. we add one row to another. Okay, so those are the three rules that you have. Generally, when I say multiply a row by a constant, I like to avoid fractions. So if I can, I'm not going to use a fraction. If I have to, then we will. But the less fractions we have, the easier it's going to be to keep track of. Any questions on those three tools? All right. So as far as how you do it, that's it. Those are the rules. So now the rest of class, we'll just practice some examples. So there's the system that we're going to solve. And the first thing I'm going to do is just translate it into a matrix. Each equation is going to be its own row in the matrix. Before you start copying it, make sure the x's, the y's, and the z's are all lined up. If you have x's, y's, and z's in different columns, you need to fix that. Okay. But how about here? Are all the x's, y's, and z's in the same columns? Yes. Yeah. So then that's fine. Okay. So we're going to start writing it as a matrix. So we're going to have 0, 2, 1, -8. 1, -2, -3, 0. -1, 1, 2, 3. There is a lot of copy. So you really need to make sure you copy it right, because if you copy one number wrong, then the whole thing comes out wrong. So double check it. Usually what I do is if when I write them down, if I read them left to right, when I check it, I'll read them up to down. So 0, 1, -1, 2, -2, 1, 1, -3, 2, -8, 0, 3. Looks good. Okay. This is the order you always have to go in. Okay. We want to get the ones on the main diagonal and zeros below. But there's a certain order you have to go in. If you don't go in this order, sometimes you end up going in a circle. Like you'll fix one thing to be a 0, and then when you try to get something else to be a 0, you mess up the one you just did. But if you follow the order I'm about to give you, you'll never have that problem. Okay. So the first thing we want to do is get a 1 in that spot. Are there any rules that I gave you from the previous page that could help you to get a 1 up here? Yep.
You can swap the one below it to go above.
Yeah, we're going to swap rows 1 and 2. Okay, so I'm not going to write that out in words. Swap rows 1 and 2. What I'm going to do is this. When I circle a number, it represents a row. So I'm going to take row 1. I'm going to take row 2. And that's the symbol I use for swap. Now, if I was doing this problem, I would probably do something else at the same time, because it's a lot of writing to copy the whole thing over just to swap 1 and 2. But I want to show each step one at a time. So let's write it again. So now, put row 2 at the top. 1, -2, -3. Actually, you know what? I'm going to do it down here, so I have more space. 1, -2, -3, 0, 2, 1, -1, 1, 2. And also make sure you swap the other numbers that go with them. 0, -8, and 3. So I just took rows 1 and 2 and swapped. Okay. Any question on that? So the first step was pretty easy. We got a 1 in this spot. The next thing you want to do is you want to get a 0 here and here. Well, we already have a 0 in one spot. So row 2 is actually fine. We don't have to do anything with it. But I've got to get a 0 in this spot. All right. So now, the way we're going to get a 0 here is you're going to do something with row 1. Is there anything you could multiply row 1 by and then add it to row 3 so this number becomes a 0?
1.
Yeah, you don't even have to multiply by anything. Just basically multiply it by 1 and then add it. So really just add it. Okay, so that's our next step. So row 1 is going to stay the same. So let me write that down. Row 2 usually has to be fixed, but in this case, there's already a 0 in that spot. So we can leave row 2 alone.
So that's the next step, is to get the 2 below the 1.
Yeah, the next step would have been to get a 0 here.
But we already had it, and then the next step after that is to get that one.
To get a 0 here. Yep. So you deal with the first column. That's what you do first. Get the first column straightened out. So this stays the same. And now, so we don't forget what we're doing, I'm going to write down what we're doing. We're going to take row 1. We're going to add it to row 3. And that's going to replace what's in row 3. So the way we're going to write that is like that. So we're going to add row 1 to row 3. And that's going to give me a brand new row 3. This row 3 is going to disappear. All right, so let's do it. What's 1 plus negative 1?
0.
So that's 0. And we'll do it all the way. Row 1 plus row 3. What's negative 2 plus 1? Negative 1. Okay, let's do it again. What's negative 3 plus 2? Negative 1. And what's 0 plus 3? 3. Now what you basically have at this point is you have 2 equations, and they each have 2 letters. This middle equation is 0x plus 2y plus 1z equals negative 8. And 0x minus y minus 1z equals 3. So we got rid of the x in the second and third equations. Now we're going to get rid of something else. Okay. Any questions on that? 1, 0, 0. Yeah.
We have to go over how to get that one, like the second row, the 0, 2.
Now we need to get a 1 right here. That's the next step. There's a couple ways we can do it. I have a certain way that I'm kind of leaning towards here. How can we get a 1 right there using one of the rules from the other page? Yep.
Adding row 2 and 3.
Yes. You could add rows 2 and 3 together and replace what's in row 2. That's one way to do it. Or, what's another way?
Multiplying by, dividing by 2.
You're going to say it as multiplying.
Multiplying by 1/2.
Yes. You could multiply this row by 1/2. Makes all the numbers a little smaller. Makes that a fraction, but that's not that bad of a fraction. And you'll get a 1 there.
But to avoid the fraction, when we just do what I would suggest, and just add row 3 to row 2.
We could. Yeah. This time you could. You're lucky that this is a negative 1 and that would work out perfect. That doesn't always work out that way. So we can decide which way do we want to do it. Multiply row 2 by 1/2 or add row 2 and row 3. Okay, so let's add them up because there's no fractions. So we're going to do row 2 plus row 3. And we are going to replace what's currently in row 2. So rows 1 and 3 are not changing. We're just going to replace something in row 2. So let's copy down rows 1 and 3. Now, add row 2 to row 3 and replace what's in row 2. Okay. What's 0 plus 0?
0.
0. It's always safe to work with a row that's below, and you'll never mess up what's above because you all have all zeros there. You would not want to add row 1 to anything at this point. Then you'd mess up these zeros. Don't want to do that. Okay. What's 2 plus negative 1? 1. What's 1 plus negative 1?
0.
0. And what's negative 8 plus 3? Negative 5. Okay, so we got the 1, we got the 0, we got the 0, we got the 1. Now I want to get a 0 right there. And once I get a 0 here, I will have gotten rid of the x's, the y's, and the only thing left in the bottom one will be a z. And then I can solve for my first letter. And then at that point, we're pretty much done. Okay. How are you going to get a 0 in the number that has a box around it? Yep.
Add 2 to row 3.
Yeah. I'm going to add row 2 to row 3 again. And this time we're going to put the answer where?
In third column.
In row 3. So rows 1 and 2 are going to stay exactly the same. 1, negative 2, negative 3, 0. 0, 1, 0, negative 5. And let's add them up. 0 plus 0 gives me
0.
0. 1 plus negative 1 gives me
0.
0. 0 plus negative 1.
Is negative 1.
And negative 5 plus 3. Negative 2. Once we get 2 zeros here, like that, you're really done with the matrix. You don't have to get the 1 here. Because what does this last row say if you converted it back to something with letters? Tell me the whole thing. Yep.
Negative z equals negative 2.
Can you tell me about these first two?
Oh, sorry. 0x plus 0y minus z equals negative 2.
Yep. So we got rid of the x and the y. So really that last row says negative z equals negative 2. So what does that mean z equals?
2.
It is 2. Now, let's go back up to the next row. What does that second row tell me?
Y equals negative 5.
Yeah, we don't even have something to substitute in. We got lucky, there's a 0 here, that usually doesn't happen. But that second row tells me 1y plus 0z equals negative 5. So we automatically get the second row. And now let's go back up to the top row. X minus 2y minus 3z equals 0. Now you have to substitute in the two things you know, and then we'll find x. Okay, what's y?
Negative 5.
Negative 5. Okay, what's z? 2. All right. So what's negative 2 times negative 5?
Negative
10.
Positive 10. And negative 3 times 2?
6. Negative 6.
Negative 6. 10 minus 6 gives me positive 4. Which means
negative 4.
x is negative 4. And that's a pretty typical problem with a matrix. Okay, it takes a little bit to get used to, but if I had to solve 3 variable systems, I prefer to do it this way than to try to do elimination.
No, on the test or anything, it doesn't matter which way you do it.
It won't matter, but it might be set up to do a certain way. So if you don't pick the way that's easier, it may lead you into taking a lot more time.
Okay.
And you can always solve any of these problems any way that I've taught you. But some ways are a lot faster.
Like this.
Yeah, this was really good for a matrix because we had a lot of things that just happened nicely, like getting a 0 here, getting a 1 here really easily. This one was kind of set up to help you out. All right, any question on that one? All right, let's try. Okay, so let's try this one. Okay. Does anyone notice anything about these equations? Any comments at all? Yeah?
We're missing a Y.
Okay, we're missing a y in the top. That's great, because it's a 0. So we can, when we do our matrix, we can already fill in a 0 for that y. Zeros are just easy numbers to work.
So if you're missing a variable, just put the 0.
Yep. Yeah, you gotta fill in something. So if you're missing it, it's plus 0. Anyone notice anything else? Yeah?
The middle row is divisible by 2.
Yeah, the middle row is divisible by 2, so before I even start the problem, I'm not even going to count this as a step. I'm just going to divide everything by 2 in my head. Okay, that way I don't have to deal with, not that those numbers are that big, but I can make them all half as big. Yeah. And what number do we want to get right away in the upper left?
1.
A 1, and the top equation, what's the number in front of x?
1.
It's 1. So we already have a 1. We do not have to do that row swap this time. Okay, it's already in the right spot. Okay, so what's my top row going to be in my matrix?
1, 0, and 1.
1, 0, 1, 4, and 4. Okay, now dividing everything by 2, what's going to be my next row?
1, 2, 5.
1, 1, 2, 5. 5. And what about your third row?
1, 6, 8, 4.
Yep. Now, you might think, ooh, we were supposed to get a 1 here later on, and we already have it. That means nothing. You have to get zeros in these spots first. Okay. So, if you already had a 1 in the middle, that 1 may get messed up. Okay. You've got to get zeros in the first column. Okay, so we already have the 1 in the upper left. Now we're going to try to get zeros here and here. Okay? And this is really the only time where I do 2 things in one step. Okay, I do 2 things in one step. What could we multiply row 1 by? And then add it to row 2. So that number becomes a 0. Yep.
Negative
-1.
1.
Yep. So we're going to do -1 times the first row. We're going to add it to the second row. And that's going to take the place of what's in the second row right now. All right. Now, let's do it again. I want to get a 0 in this spot. What could I multiply row 1 by? So I can cancel this number out.
-1.
-1 again, just a coincidence, but that's what it is. So -1 times the first row, added to the third row, and where am I going to put the result?
Third row.
Third row. Yeah. So what row isn't going to change at all?
Number 1.
Yeah, so let's copy that over. That row's not going to change for the entire problem. 1, 0, 1, 4. Once you get a 1 in the upper left, the first row, you're done with that row for the whole problem.
So even though you're doing like multiplying it by -1, still doesn't change at all.
Right, I'm multiplying it by -1 and I'm adding it to row 2 and I'm replacing what's in row 2.
So you can do things to rows, but as long as you're using that row that you just changed to another row, if you don't change, like your finished product is in that row, it doesn't change.
Right, multiplying row 1 by -1, that's just something I'm doing in my head.
Okay.
What's really important is we're changing row 2.
Because you could just as easily, if you don't put it onto long division, then multiply it by -1 again and get it back to what it was at the start. So it doesn't change at all.
So alright, let's go through it. Multiply everything by -1 and add it to row 2. Okay, what's 1 times -1?
-1.
Plus 1. 0. Okay. What's 0 times -1?
0.
Plus 1. 1. So the only reason that didn't get messed up is because there was a 0 above it. If it wasn't a 0, it would have just changed. Okay. What's 1 times -1? Plus 2.
1.
1. Okay, one more time. 4 times -1?
-4.
Plus 5.
-20.
No, just 1.
-4 plus 5.
1.
Now, we're going to do the bottom. Multiply row 1 by -1 and add it to row 3. Okay, so what's 1 times -1?
-1.
Plus 1.
0.
So we get a 0. What's 0 times -1?
0.
0 plus 6. 6. Okay. Times -1. -1 plus 8. 7. And times -1? -4 plus 4. 0. Okay. So now we got zeros in the first column, and we ended up with a 1 right here, which would have been my next step. Okay, but this time it's already a 1. Last time we had the option, I think, of multiplying this row by 1/2. We did it a different way, but we don't even have to change it this time. So now the last thing we want to do is get a 0 right there. So using row 2, what could you multiply row 2 by?
-6.
Right.
And then plus, and then add it to row 3.
You multiply it by 6 and then add them.
-6.
Or -6 and then add them, and the second row won't change because you don't have
The second row is done for this whole problem. Yep. No more changing the second row. So we're going to do -6 multiplied by row 2. That's just in our head. We're going to add that to row 3. And what we're actually writing down is a new row 3. So rows 1 and 2, just copy them over. 1, 0, 1, 4. 0, 1, 1, 1. Okay, so multiply by -6 and add to the third row. What's 0 times -6?
0.
Plus 0.
0.
0. You're never going to mess up that first column if you follow this. That will always stay zeros. Okay, what's 1 times -6?
-6.
Plus 6.
0.
0. And then 1 times -6?
-6.
Plus 7.
1.
1. And 1 times -6?
-6.
Plus 0.
-6.
-6. Now, let's look at that last row. What does that last row tell me?
That C equals -6.
Right. It says 0x plus 0y plus 1z equals -6. So there's your first answer.
You don't always have Z then, right?
When you do the matrix, you always have z. I mean, if this isn't a 1, like let's say it was a 2, then you would have written 2z equals -6, and then you would have divided each side by 2. So yeah, the matrix pretty much gives you z. You just may have to divide by that number. Okay, what does the second row tell me?
That Y plus C equals 1.
1y plus 1z equals 1. And what's z?
-6.
Okay, so y minus 6 equals 1. And that means y is
7.
7. Okay, y is 7. Now go up to your top row. What does that top row tell me?
X plus Z equals 4.
1x plus 0y plus 1z equals 4. And we don't know x, but we do know z. What is z? -6. So what's x?
10.
10. So x is 10. And that's the whole problem. Now, if fractions get involved, then it gets pretty messy, but usually we try to make the problems like that. Any questions on that? if fractions are involved, it doesn't change how you do anything. It just, the arithmetic in your head is a little harder. And I find if I can just keep going, like times this, add this, times this, add this, if I can just keep going, I don't lose my place. Like if I'm in the middle of doing it and somebody comes and talks to me, it's almost like I have to start over because then I forget what I was doing. So going back and forth to a calculator, you can kind of lose track of where you're at. Any question on it? All right, we'll try one more. And then that'll be it. Okay, and again, I keep showing them to you, but really until you try, that's when you kind of start to wrap your head around it a little more.
This is like all over the place.
What's that?
So this is like all over the place.
All over the
It's
place.
hard to keep them like in order. I don't know, cause like when I'm writing it down, like it's hard. I run out of space going this way, so I gotta drop it down.
Oh yeah, if you run out of space on your paper, that's why I try to set it up so that like I work left to right, one row at a time.
Mm-hmm.
That's how I try to do it. Otherwise, yeah, it starts to get messy. All right. Now, there's a step this time I'm going to do before we even really start. What's the very first thing that we want to have happen? Yeah?
Fill in the Z at the top row.
Okay, so we're going to have to fill in a 0 for that Z, which is nice because zeros are easy numbers to work with. But what about in the matrix? The first thing you always want to get is what?
X to be 1.
So you want to get a 1. Can you tell me where again?
In the upper left.
Upper left. Is there a way we can get a 1 in the upper left?
We can swap the rows.
Yeah, we could just swap rows 1 and 2. That would be the easiest way, and I'm going to do that. I'm not even going to count it as a step. I'm just going to write my problem that way. So my top row is going to be 1, 3, -1, -3. What's my middle row going to be?
2,
-1,
1, 0.
2, -1, 0, and
0.
0. So we swapped rows 1 and 2. And what about row 3?
0, 3, 1, and 8.
Yeah, now this 0 is very helpful. That's a 0 that we need to get right now, and we already have it. So we have the 1, we have the 0. The only other thing we want to do is make that a 0. So I'm going to write down what I'm going to do. I'm going to do it, and then that's going to be it for that line. I will go to a new line now on your paper. Okay. So what can you multiply row 1 by?
-2.
Yep. So do -2 times the first row. We're going to add it to the second row. And that's going to replace what's in what row?
Second row.
Second row. Okay. So what rows are staying the same?
1.
1 or 3.
1 and 3. I like to copy down the ones that aren't changing right away. So 1, 3. Okay, so multiply everything by -2 and add it to the second row. Okay. What's 1 times -2?
-2.
Plus 2.
0.
So we get a 0. What's 3 times -2?
-6.
Plus 1. Oh, no, I said -6 plus -1. -7. Okay, and then multiply what's -1 times -2?
2.
Plus 0?
2.
2. And then -3 times -2?
6.
Plus 0?
6.
6. Okay, so we got the 1, we got the 0, we got the 0. What's the next thing that we want to happen?
You have to get a 1 in the middle.
I get a 1 right there.
Damn.
Now, one way to do that, you could multiply everything by -1/7. Okay, if you multiply everything by -1/7, you'll have 0, 1, and then you're going to get some fractions. Does anyone see another way that we could maybe not get a 1 here, but we could get something pretty close to a 1 doing something with this row. Yeah, if you multiply that bottom row by 2 and then add it to what's up above it, you'll make that a -1. And that's fine. If you make it a -1, we can fix that. That's right. Right, so let's multiply the bottom row by 2 and add it to the middle row. So 2 times bottom row. We're going to add it to the middle row, and that's going to replace what's in the middle row. So what rows stay the same? 1 and 3 stay the same again. Okay, so 1, 3, -1, -3. Okay, so double what's in the bottom row and add it to what's above it. Okay, what's 0 times 2?
0.
Plus 0. What's 3 times 2? 6 plus -7. -1, that's fine. That's easily fixable. You can easily fix that. Just multiply that row by a negative and we're good. Okay. What's 1 times 2?
2.
Plus 2.
4.
And 8 times 2?
16.
Plus 6.
22.
22. Okay, now it's kind of annoying just for this one step, but what can we do now? Instead of having a 1 there, make it a 1 instead of a -1.
Multiply that by 1.
Right. So we're just going to take -1 times the second row, and that's going to replace what's in the second row. If you feel real confident, you could try to do 2 things at the same time, but I think you're going to lose track of what you are. So just write it again. 1, 3, -1, -3. Okay, and what do you get if you multiply everything in the second row by -1?
0,
0, 1, -4.
22. Okay, so now we got the 1, the 0, the 0. We got the 1. What's the last thing that we need to do?
Make that 3 a 0.
Yeah, make this a 0. So what can we do with the row that's above it to make a 0 in that spot?
Multiply the first row with -1.
We can't use the first row anymore.
We can't.
Because if you multiply anything in the first row by a number and then add it, you're going to mess up this 0 and then you go in a circle.
Oh,
Fix something, mess something up, and you just keep going back and
You
forth.
can multiply the second row by -3.
To take the second row, you're going to multiply it by -3, and then we're going to add it to what row?
3.
3.
Yep. And that's going to replace what's in
Third row.
third row. So what rows stay the same?
1 and 2.
So just copy them over. Okay, so now multiply by -3 and add. What's 0 times -3?
0,
Plus 0.
0,
1 times -3
-3.
-3,
plus 3.
0,
Perfect. 4 times -3
12,
plus 1.
13,
15. And -22 times -3.
66,
66 plus 8.
74,
Any question on that? All right, now, what does that last row tell me?
you need to get a 1 where the 13 is.
Well, we could get a 1 where the 13 is, or what if you just write it back out with letters? What does it say?
13z equals 74.
13z equals 74. And how would you solve for z?
Divide by 13.
Divided by 13. Okay, and I'm doing this one with fractions because you can get fractions. We didn't get fractions through the whole problem.
So you necessarily don't need to get, where like on the bottom row where it's z, you necessarily don't need to get 1.
No, I mean, you could say, all right, now I'm going to multiply this row by 1/13. And then you get 0, 0, 1,
I don't know, but yeah.
74/13 if you multiply by 1/13.
Okay.
It's exactly what we just did right there.
Alright.
Okay, so we got Z. What does the second row tell me?
Y equals 1 and Z equals
So we got 1y
and -4
negative 4z
equals -2.
equals negative 22. And what do we need to fill in for z?
74 over 13.
74 over 13. So kind of annoying. We have a fraction, but we're at the end. So we're not trying to keep track of the steps anymore. We just need to type all that in on the calculator. Okay, so I'm going to do -4 times 74/13. Right, and I'm going to use that button I showed you earlier to change it to a fraction. Math, fraction. Negative 296 over 13. 296 over 13. And what would be our last step to get y by itself?
Add the fraction to the other side.
Yeah, add the fraction to the other side. Which again, I'm not going to do by hand. I'm just going to do negative 22 plus 296 over 13. Okay, messy decimal. How can I fix it so it's a fraction?
Math.
Yeah,
Fraction.
fraction. 10/13. So there's y. And the last letter we need is
X.
x. What does that top row tell me?
X
Plus
plus
1.
X plus 3y
Minus Z equals -3.
3. Okay, x we don't know. What's y?
Y is 10/13.
10/13. That I can do in my head. When you triple 10/13, it's 30/13. So I'm just going to write that. So there's y tripled. And what's z?
74 over 13.
So 74/13. Okay, and I know they already have a common denominator, but I don't even want to think about it. I'm just going to type it all in. So I got 30/13 minus 74/13. Okay, and what can I press? Fraction. So that's negative 44/13. And my last step,
To add the 4/13 to -3.
so take negative 3 and add 44/13. And again, it looks like a messy number, but I'm just going to change it. 5/13. So I wouldn't expect a lot of them to be fractions, but it is possible you get one that's a fraction. Okay, so we're just going to practice that again tomorrow. So tomorrow will be a review day. We'll go over the homework, and then there will be 5 questions like that to do after the homework. So if you can get done 2 or 3 in class, you only have 1 or 2 questions left. Let me double check that. That is not all solving 3 variable equations. That would take a while. Okay, some of it is just saying, here's a matrix, what are the dimensions? You just have to say how many rows and columns. That's like 1 through 6. Okay, so 1 through 6, you don't have to solve anything. Those are very simple. 17, 18, these are actually review questions from yesterday.
With the matrix,
What's that?
with the matrix, It's just like the amount of rows and columns. So like if it's 3 variables, then it's 3,
3 columns.
and then if it's the amount of equations, it's the amount of rows.
Yeah. Yep. 21 and 24, that's like what we did in class. So you have 2 problems like we did, and 31 is a word problem. So we'll take a look at that tomorrow.